Hello everyone, my name is Michael Nevarez, an electrical engineering student at New Mexico State University. In this video, I'll be explaining and demonstrating the use of a solderless breadboard as part of the first lab assignment for the engineering course ENGR 120 DC Circuit Analysis, Spring Semester 2025. This interesting looking device is called a solderless breadboard, or just breadboard for short. The two sections in the middle of the breadboard contain numbered columns that run the length of the board, each with 5 holes, themselves labeled with letters. Each hole within a column is physically connected to each other via a hidden wire that runs within the board itself. The columns themselves, however, are not connected to each other, creating an array of separated hidden wires, each 5 holes tall, running the length of the breadboard. There are 2 additional lines of holes along both the bottom and top of the breadboard, each flanked by either a blue line labeled with a negative sign or with a red line labeled with a positive sign. Unlike in the numbered columns, each hole here is connected horizontally by a hidden wire that runs the entire length of the breadboard. The same holds true for the other separated blue and red labeled rows. The breadboard is further divided into 4 distinct segments, each of which are separated, yet contain holes that are connected in much the same way as previously described. Each hole is designed to receive small electrical wiring, such as the one seen here. The wire tip is inserted into a hole and is held firmly in place by a metal element within the hole. These wires can then be easily removed and replaced as needed, allowing for quick and easy adjustments to the circuit layout being tested. We can also add other kinds of electrical components, such as this resistor, to the breadboard. In a similar manner to the previous wire, the resistor can be placed in the breadboard with each tip inserted into different holes. In this instance, the ends of the resistor are connected to holes from different numbered columns, effectively connecting the 2 previously disconnected hidden wires of the 2 columns. Now we can dive into a demonstration of how components inserted into our breadboard interact with each other. For the purposes of this demonstration, we will be using a digital multimeter to measure resistance, which is a property of electrical components to slow down or resist the flow of electricity through a circuit. We will power on our multimeter and set the operating mode to ohms, which is the international standard unit of resistance. The display will show a reading of OL megaohms, which indicates an overload, meaning the resistance is currently higher than the multimeter can measure. This is because there is no direct electrical connection detected between the multimeter sensors, only air, which provides extraordinarily high electrical resistance. This then, for all intents and purposes, is our default reading when no electrical connection is detected. Using 2 mini hooks connected to our multimeter, we can hook up our multimeter to the breadboard and demonstrate its functionality. To start, we'll hook up the leads directly to each other and show what a direct connection looks like. The multimeter reads 0.0 ohms, showing that there is effectively no resistance to the flow of electricity. Next, we'll hook up our multimeter to the blue wires connected across the bottom positive row. As expected, the multimeter shows a reading of 0.0 ohms, demonstrating that this row is directly connected along the whole length of the breadboard. We'll then connect 2 holes directly adjacent to each other, but one along the negative row and the other along the positive row. We get a reading of OL megaohms, indicating that though the holes are directly adjacent to each other, the hidden wires they are attached to are not directly connected. Let's move on to the numbered columns. When we test the wires inserted into column 55, we get a reading of 0.0 ohms, indicating they are in fact directly connected. Now connecting the hooks to wires in different columns results in a reading of OL, indicating no direct connection. Lastly, we'll connect our hooks to wires situated in the same columns as those of the resistor. This one is designed to provide 5.1 kiloohms of resistance. The multimeter displays a reading of 5.06 kiloohms, well within the allowable variation for this kind of resistor. This demonstrates that the 2 columns, though separated within the breadboard itself, are now connected through the resistor. I hope this video has been helpful in demonstrating the uses of a breadboard in designing, laying out, and testing circuits. Thanks for watching, and I'll catch you again soon.